And now I'm going to talk about the background of our system. Our system is AI Healthcare Assistant. It is a concept of monitoring and detecting human heartbeats. It's used the AWS cloud platform to increase the productivity and the quality of the existing system, which can remove the traditional way which need nurse to check only during the check-in time. The IoT core might be involved in sensing devices such as heartbeat detector, smartwatch, and etc. We are using cloud platform to develop our system, and some software application might be involved in it too. And now I'm going to talk about the history of traditional ways of heartbeats detecting. As we all know, the hospital is used the heartbeat detector to detect the heartbeats, but it is only manual checking by the nurse on certain time. They will only ring the alarm when there is someone who found the patient having abnormal heartbeats, which will lead to missed prime of rescue time.
Good day, sir. My name is Tai Jingshuan and my student ID is 20ACB057447. Now I'm going to discuss about the future trend of AI in healthcare assistant. So in recent years, the implementation of AI in healthcare assistant has revolutionized the technologies used in the industry. Firstly, medical imaging analysis is a major application of AI healthcare assistant as it can enhance the diagnosis of abnormalities and diseases. Medical imaging analysis aids doctors to analyze medical images such as X-rays by interpreting and segment images automatically. The AI algorithm implemented will help healthcare providers to identify areas of interest with clearer visualization and get more comprehensive understanding. Besides that, virtual assistant is also one of the uprising trends in the AI healthcare assistant industry. Virtual assistants such as chatbots will be easily accessible by everyone all day long to get advice and support for basic medication information. It can help patients by answering common medical inquiries and direct patients to the professionals when patients need additional help. Virtual assistant can also offer medication and reminders to the patients to take medicine at certain time and schedule upcoming appointments with doctors to ensure patients receive timely care. Moreover, AI-powered predictive analytics is one of the popular trends in the field. It assists healthcare professionals to identify patients who are at risk of developing diseases such as chronic disease and suggest preventive treatment to doctors before it gets worse. AI algorithm is used in this predictive analytics to analyze patient data based on genetic makeup and medical conditions. This can help doctors to do early interventions and develop personalized treatments for patients, reducing the possibility of adverse reactions.
One of the most difficult challenges in developing and deploying AI healthcare assistant system is must assure their accuracy and stability. Another concern is ensuring that AI assist healthcare system follow the regulatory and ethical requirements. AI algorithm, for example, must preserve patient privacy and confidential. Besides, is the need for healthcare professionals to receive special training. Even though AI can aid in the diagnosis and treatment patients, it is crucial that medical professionals comprehend how to utilize the technology and interpret the result. There are also ethical concerns regarding to the use of AI in decision making. AI algorithm can make prediction and decision based on the data pattern, but it is essential that this decision must be fair, transparent, and impartial.
Thank you for the previous presenter. And then my name is Wong Teng Wei. Now I would like to present the objective of our proposal system. The first objective is to build a system that is able to monitor patient 24 hours in real time by using data from connected IoT sensor device. The next objective is to detect any unusual pulse, such as the sustainable high beats per minute, and able to send the alert message to the medical staff, email or mobile phone in case of emergencies. The third objective is to visualize the patient pulse data for helping doctor to analyze the trends and patterns of patient pulse rate. And the last one is to forecast a specific patient future post data by collecting and analyzing his or her historical data. So this is the architecture diagram of our pop-up system. At below of the diagram, we also use the AWS Chronicle service to create user pool for patient and doctor. An API gateway will be implemented as a login and register interface. Mainly is to renew the access token of patient account and doctor account for allowing them to do operations such as create, delete, and update the data to the DynamoDB. So on the left-hand side is the IoT core, which is used to establish the communication between the IoT sensor device and the AWS service. So once the communication established successfully, API gateway will be implemented to receive the put request for uploading the post data captured by the IoT device and store it in the DynamoDB. A Lambda service below DynamoDB is to detect unusual post data from the DynamoDB. Then it will trigger SNS, simple notification service, to send alert message to the subscriber of the topic. The path at the right-hand side of the DynamoDB is for doctor to create and get patient data from DynamoDB. An API gateway will be implemented as a web interface for the doctor to create new patient and view patient data, include the post data. The Lambda is to handle post and get requests from the API gateway to trigger the function to save and retrieve patient data from DynamoDB according to the request. Above the DynamoDB is the path to visualize patient post data. A Lambda function is used to separate the patient data and store each patient data with JSON file format in a specific S3 bucket. After that, an Athena service will be used to query the data that is stored in the S3 bucket by using the SQL command. Then a QuickSight service will be used to visualize the formatted data that stored in the Athena so that the medical staff can customize the dashboard according to patient ID and a timestamp by using the QuickSight service. Last but not least, an AWS forecast will be implemented to forecast a specific patient health data that has been stored in S3 bucket.
So the IoT platform for Azure is known as IoT Hub. It is a platform provided by Microsoft Azure to act as a central message hub for IoT application communication to connect virtually to any devices. It is a cloud-hosted solution that enables secure connection, monitoring, and management of Internet of Things IoT devices. On top of that, IoT Hub is integrated with Azure Event Grid and serverless computer to simplify IoT application development. Several messaging patterns, including device-to-cloud telemetry and request-reply method, are offered to control over devices from the cloud. Now I'll briefly introduce you on how to create IoT core in AWS. So firstly, you will type IoT core in the search bar under the console page, and with that you will get this result. So you click on the first one, then you will be directed into this AWS IoT page. Under the left navigation bar, you go to Manage and you click on Things. When you're directed into this Things, you click on Create Things. So when you create things, you just select the Create Single Things and then click on Next. And you can name your things as you like. So for us, we are developing a smartwatch, so we name it Smartwatch Pulse Sensor. And then other than that, you will just keep all this default setting and then you click on Next. So when you're under the Configure Device Certification, you just click on the Auto Generate a New Certificate and then you click on Next. So you can create policy over here and you name the policy as Smartwatch Pulse Sensor Policy. Then when you're under this policy document session, you click on the builder format and then you choose allow for the policy effects. And as for policy action and policy resource, you just remain as this. Then you click on create. After that, you attach the policy to a certificate by clicking it over here, and then you click on create. So you will be directed to this device certificate. So you need to download all this key in the file like so. Keep it in your local drive, and then you click on done. So just like what I've shown just now, you just keep it in your PC, and then you will have to repeat the same step for creating new things for mobile application. So for our project, we have already created smartwatch pulse and mobile over IoT. Moving on to this IoT SDK in AWS. So you can download the coding from this GitHub link, and then you open the Visual Studio Code to open the folder. So when you open the code in the Visual Studio Code, you can see this is the patient ID, and then this is key path and cert path, which are saved in our document previously. Okay, so for now, I will just keep it in mobile and the sensor folder, and then the key path is required from this pen key, and this cert file is required here. For host and port, just remain it as this. And then moving on, this is the ID token that is required from Postman. So you can get this token ID under the patient sign up, and then you go to authorization. Under current token, you just go to the use token types, and then go header and copy everything and paste it over here. So once you paste it, you can move on. This is the sensor ID, and this is the user email. Okay, so when everything's done, go to the terminal and then type node./mobile.js and enter. So when you see this connect, it means successfully. And then at the right side, you just click node./iot.js and then enter. So once it's connected, you start getting the heartbeat. We will just let it run for a while. Okay, then you can click by Ctrl+C. Search DynamoDB in search bar, and then go into it. So under the table, click on the patient, and then click explore table forms, and then click this one, the user ID chosen just now. And then from the pulse, we can see from here, the records are stored in DynamoDB.
And now I'm going to introduce you the Postman API, which used to connected with the connector to use for user doctor login or patient login or sign up. So let's go to the page, the Postman API. We can create the collections, new collections, and after the collections, you can add a request. So yeah, add a request. After you add a request, you can configure all the things inside will become like this one. So after you configured, you can get new access token, which is sign in or sign up. So if you have account, you can sign in. Proceed. Then we can use for the token. Access token must be changed to ID token. So if we are using access token, it might be not able to use the first function. And this one should be empty at first, which get from the patients, go back to your ID, and you can copy the user ID into here. Yes, copy into here. Then the Gmail must be sent with your login Gmail. And now you can send the request. While waiting for a request, yes, after you request, you can get the query packet. That means it's successfully registered. And now you can go to the doctor side. The doctor side, same configuration with the patients, everything same, just the name is different. And doctor can get the patient ID by using the options, and this URL might be get from the Lambda. Search for Lambda and DynamoDB and go to the configurations, triggers. You can copy the URL here. Copy the URL, go back and paste here. After you paste here, then you can send the request. After you send the request, the patient's information or the BPM timestamp will be located here. There might be a functions that the token is expired, so you must go to the doctor site to get a new access token, which is sign in again to renew your token. And use token. Yeah, the access token must be changed for ID token. That's all my part, so thank you.
Hi Miss and everyone, my name is Juman, and now I want to show about how to detect the unusual post data and trigger notification by SNS services. Okay, this is our topic. We just create a topic, name the message alert. This is our SNS services. In this SNS services in the below, this you can see the subscriptions. In subscription, we can see the subscriber IDs and also their phone numbers and also their emails. Okay, we also use the Lambda functions to trigger the notifications by the SNS services and the API gateway. By the source code, we use the index.js. We create a topic ARNs like this. Okay, this topic ARN is copied from the SNS services from this ARN. Okay, just copy and paste it into this code. And also we use the Visual Studio Code. Before we use the Visual Studio Code, we just create to use the herd price rate by store in the DynamoDB. Then we just comment this line, and also we trigger the high herd price rate for the BPM. Okay. In this mobile.js, we also use these functions. Okay. We also use these functions. In these functions, we use the post method to send the message to the API gateway, and also send the SMS message alert to the subscriber. Okay, to run these two functions, we just use the terminal to open these two command code line. We just create enters. Just wait. Okay, you can see connect and subscribe. An Azure message is sent successfully. Okay, when the successfully is sended, we just press C to stop the command, and we just press C to stop the commands. And you can see at the website, you can directly go to the email. You can see the AWS notification message is sent to the message for the subscribers. An Azure message sends a patient has a certain VPN, and this is the patient emails and also the patient ID. Okay, okay, that's all for my part. Thank you.
Miss, my name is Wong Peng Wei, and right now I would like to present how to visualize the patient data by using the QuickSight. So, in our DynamoDB, we got in the patient table, we got the patient ID, patient email, and the array, the post data as an array that store the timestamp and the BPM value, the post value. And then we're using the Lambda function to separate each of the patient data and then store it in the S3 bucket. So here's the bucket name is the Dynamo JSON backup, and then the parameter we refer to the DynamoDB table, the patient DynamoDB table name, and then under is the function to separate each of the patient data and then store it in the DynamoDB, the put object to S3 bucket. And the following is the bucket name, file path, and the array file content. And then need to click the test, and then if it show the 200 success, which means our function is successfully executed. And then right now in the DynamoDB, in the S3 bucket, you can see our S3 bucket name Dynamo JSON backup, and then it's contain the JSON file that we have just created by using the lambda function. And by using the S3 bucket, the data in the S3 bucket, we can use the Athena to query the data, because initially the data in the bucket is like this. This is not formatted, and the post data still in the array type. So we need to extract it separately as a BPM and a timestamp. And then we use the SQL command like this, select the patient ID, email, and then extract the post data BPM and then the timestamp. And then we click run again. Yeah, it's the formatted data we got by using the SQL command. So you can see the post data already separate as the BPM and the sensor time. So by using this formatted data, we can now go to the quick site to visualize it. So the user can use the patient ID and or the timestamp to filter the dashboard. And then next is how to forecast the patient future post data. So in S3 bucket, we got the BPM value and the timestamp. So we can use the AWS forecast service to forecast the future post value. And then we can need to give the start date and then the end date, which we need to forecast until which date and time. And then we click get forecast. Yeah, so we can see visualize the data from the start date to the end date. And then the gray color area is the patient data we original got. And then the color one, the orange color, green color, and blue color is the one the system forecast. And that's all for our presentation. Thank you.